Now I am going to discuss cells, batteries, fuel cell, corrosion and galvanization. So cells are categorized into two, primary cells and secondary cells. So at very first let me discuss what are the primary cells. Children, primary cells are those cells in which electrical energy is produced by the reaction occurring in the cell, like Daniel cell, dry cell, mercury cell, etc. But mind one thing, these primary cells are used one time only. It cannot be recharged. It is okay. What is the major difference between primary cell and secondary cell? Primary cells are used once only. Means these are disposable. So common examples: dry cell, mercury cell, and Daniel cell. Let we have to discuss some of the primary cells. Dry cells. This is very common cells, which we are using in our home appliances, torch, etc., in radio transistors. So in dry cell, mainly two reactions are there at anode, at cathode. At anode, zinc rod undergoes to oxidation, finally provides zinc cation by losing two electrons. And at cathode, there is the paste of manganese dioxide and ammonium chloride. So MnO2, manganese dioxide, reacts with ammonium ions with excess of electron, and it gives magnesium oxyhydroxide and ammonia. So finally, net reaction we can write here like this one: Zn plus NH4 plus MnO2 is equals to Zn plus MnOOH plus NH3. So dry cells are used one time, and the cell potential of dry cell is approx 1.5 volt. It is okay. Now the next primary cell is a mercury cell. The electrolyte paste in mercury cell is considered to be the potassium hydroxide and zinc oxide mixture. What is the electrolyte paste? In this mercury cell, electrolytic paste is of KOH, potassium hydroxide, and zinc oxide paste. So here once again we have to go through the consideration of anode and cathode reactions. Anodic point, zinc reacts with hydroxyl radicals 2OH minus, it gives zinc oxide H2O and releases electron, 2 electron. Means at anode there is oxidation. At cathode, mercuric oxide reacts with H2O and 2 electron, it gives mercury and 2 hydroxyl ion. Overall the net reaction is of Zn plus HgO is equals to ZnO plus Hg. So the mercury cell also have cell potential 1.35 volt approx. Now after the brief discussion of primary cells which are disposable and used one time cells, dry cells, mercury cells, and already we have at very first before the last equation we have gone through the detailed study of Daniel cells, which passes two electrodes, half cells connected with salt bridge. Alright. So no matter to mention again. Let we have to go through the discussion of secondary cells. Those cells which are used for storing electricity, means in these cells we can store electricity. So common examples are lead storage battery and nickel cadmium cell. So at very first we have to go through one by one the study of nickel cadmium cell and lead storage battery. Nickel cadmium cell, it is secondary cell which has longer life, okay, and here the reactions are mainly cadmium when treated with nickel trihydroxide, it gives cadmium oxide and nickel dihydroxide and H2O. So ultimately the cell potential of nickel cadmium cell is also more than 1.5 volt. It goes up to 1.67 volt approx. Now what last there is the discussion here, lead storage battery. This is secondary cell. It is rechargeable like nickel cadmium cell. So there are, galvanic cells unit connected in series. Suppose 6-volt battery, 12-volt battery needed in series. Galvanic cells also have potential of 1.5 volt. So if it is a 12-volt battery, that's why it needed how many galvanic cell series is 8. 8 multiplied by 1.5 goes up to 12 volt. So likewise, so here the reactions are: anode, at anode, lead metal reacts with sulfate radical because there is electrolyte in solution, sulfuric acid. So inside the battery, so lead solid reacts with aqueous sulfate ion, it gives lead sulfate and releases 2 electrons. So at anode there is oxidation. At cathode, lead oxide solid reacts with sulfate ion plus hydrogen ion plus electron. It again gives lead sulfate and water. So overall reaction we can write here PbO2 plus SO4 minus minus sulfate ions plus 4 hydrogen ion plus 2 electron is equals to lead sulfate plus 2 water molecules. Means this is the overall net reaction. When we have to recharge the battery, the reaction will be reversed. Means the reaction will be PbSO4 plus 2H2O is equals to PbO2 plus SO4 minus minus plus 4H plus 2 electron. So ultimately this lead storage battery is very common nowadays. In your houses you are using inverter, and everywhere the big batteries you are seeing, children, those are of lead storage batteries and are of secondary cells. It is okay. So let me have to discuss all these things once again. Primary cell, these are these are used only one time. Dry cell, galvanic cell, mercury cell are common examples, and their cell potential is 1.5 volt only, not more than that. Secondary cells, these are rechargeable cells or batteries. Nickel cadmium cell and lead storage batteries are common example of these. And finally we are going to discuss fuel cell. Children, fuel cell are used mainly in rockets, because these are the very special cells which needed only hydrogen and oxygen in a particular device, and they are providing enormous heat, and ultimately these are very special cells. So in fuel cell, anode part 2s2 plus 4OH minus reacts and goes up to 4s2O plus 4 electron, means oxidation will take place. At cathode, oxygen treated with 2s2O plus 4 electron gives 4 hydroxyl ion. Overall reaction is that 2s2 plus O2 goes up to 2s2O. Means overall there is a combination of hydrogen and oxygen to release water, S2O, and there is the bifurcation of water again into S2 and O2. So there is recycling of water into hydrogen and oxygen, and again fuel cell needed less amount of hydrogen and oxygen and releases continuously enormous heat, high temperature due to high calorific value. So ultimately fuel cell is very special cell, and should have to go through the detail of diagram from your NCERT book. And now children, we are going to discuss very last topics, corrosion. Already you have been studied corrosion in class 10 in metals and non-metals chapter. It is okay. You know corrosion, when iron metal reacted with atmospheric oxygen under the influence of moisture, water, especially during rainy seasons. Okay, so there is an electrochemical reaction. At anode, iron goes to get oxidized to give again ferrous ions. Fe gives Fe plus 2 electrons, means there is oxidation. But at cathode, oxygen when reacts with hydrogen ion and 4 electron, it gives 2s2O water. Ultimately the rust after electrochemical process, which is called rust after corrosion, that is overall formula FeOH whole twice into X2O. This is called hydrated ferrous hydroxide. This is a brown powder this is a rust, and this decay the iron metal. So ultimately we have to protect this corrosion either by greasing or by oiling, but the best suitable method is a galvanization. Children, you know, galvanization, it is a process of coating zinc over iron so as to protect it from rusting. It is okay, and already you have been studied. So I will practice all these things in chapter 4 and practice numericals chapter 3, and tomorrow I will discuss chapter 4, and there is a chemical kinetics. So keep on preparing the notes. When in the month of July we will visit in the classroom to you children, I will see at very first your fair work, and finally I will explain, I will revise in the classroom, and I will give you the assignment papers too. Thank you. Have a nice day.